Kia ora koutou. This video is for Year 11s and for Ben, Tosif and Snehal, and for any Year 12s redoing AS. So it's the next two questions from paper 53 in November 21. I'm just doing two questions because the second of them is a quite challenging Perms and Comms problem, and I'm going to do that in a couple of different ways. I'm going to go through that quite slowly. The first one, though, is a pretty straightforward normal distribution question. The biggest thing to remember here is I want you to draw lots of diagrams for when you're standardizing. So let's do that first one quickly now. I've got the normal table chucked in here so that you can practice using that. Raj wants to improve his fitness. Sounds like a good idea. So every day he goes for a run. And the times and minutes of his runs have a normal distribution with a mean of 41.2 minutes and a standard deviation of 3.6. And we have to figure out the probability that on a random day he runs for more than 43.2 minutes. So this is a classic and pretty straightforward normal distribution question. Quickly looking at my notes. So I'm going to start off by saying X is normal with a mean of 41.2 and it's got sigma squared of 3.6 squared. So we want to find the probability that X is greater than 43.2. We're going to do that by standardizing. So we're asking how many standard deviations above or below the mean is 43.2. So we do that by subtracting off the mean and dividing by 3.6, which is the standard deviation. And at this point, a rough sketch is always a great idea. This is my X sketch. So there's 43.2, and underneath it is my very badly drawn Z sketch. So this is what we're working with. So the Z value here works out to be the probability that Z is greater than 0.556. And we can find this probability by finding 1 minus this probability, so 1 minus phi of 0.556. So at this point I whip over to the tables and have a look for the value at 0.55, and then I go over here, I want 0.556, so I'm going to my add column here. So it's going to be 0.7088 plus 20. Okay, so back to the working page. So that's going to be 1 minus 0. Well, let's just do it in our head. So 0.7088, it'll be 0.7108. You've got to get that add-on factor right to get the marks here, so make sure you're confident with using it. That gives us 0.2892. To three significant figures, that's 0.289 to 3 SF. Okay, so that's the first 3 marks. Now we have to find an estimate for the number of days in a year on which he runs for at least 43.2 minutes. So the probability that he runs for for less than. So for less than 43.2 minutes is going to be 1 minus that number. So we're back to working with our 0.7108. So the number that we want is going to be, N will be 0.7108 times 365. Now that gives me 259.4, but that does not make sense as an answer in this context. So we want to find the number of days, so we would say 259 days on which he runs for less than 43.2 minutes. Okay, so far so good. 5 pretty straightforward marks. You really have to be completely confident with the normal distribution to be doing AS stats. And the next one is what we call an inverse normal problem, where we're saying on 95% of days he runs for more than t minutes. Find the value of t. Now it was interesting reading the examiner's report on this because they said that students who'd drawn a diagram tended to get this question completely right. Right, and the diagram we're drawing is that we want to find the time on which for 95% of days he's run more than that time. So we're going to be looking for a negative Z value. Right? What we're going to do here is start with a Z value and then work back to get an X value. So looking at our normal table, there's a really useful bit down the bottom for when we've got common values. So the probability that Z is less than a number is equal to P. So if we draw this picture out, in here, working at this end, we've got a 95% probability of being below 1.645. So what we want is 95% probability of being above that number, and by symmetry that's going to give us a z value of negative 1.645. If you've drawn your diagram, you're going to get that that's a negative value straight away, I think. Okay, so the last step here is to take the z value and turn it back into an x value. So the way I go between z and x is using this. Right, this formula is one that just comes up all over. But all it means is that what we're looking for, so we can write the formula values in, right? Negative 1.645 is equal to x, which we're trying to find, minus 41.2 over 3.6. But many of you will intuitively have seen that all we're talking about here is, let's draw a normal distribution, not a triangular one. Save the triangular for level 3 stats. All we're saying is that we want the number that is 1.645 standard deviations below the mean. So x is equal to 41.2 minus 1.645 times 3.6. I guess what I'm saying is you can either start by putting it into the standard formula, or if your intuition for this is fine, you can go straight to doing it like this, right? So x is equal to mu minus the z value times sigma. And here that gives me, rounded to the nearest decimal place, 35.3 minutes. So that's my answer here. Okay, so that took 6 minutes already on quite a straightforward normal question. I'm going to optimistically start the Perms and Comms one now, but it might take a second video because there is quite a lot in it. So we're just going to do this. We're not going to bother with question 6 just yet. You've got to have a really clear understanding of the setup here before you start. You're trying to work out the number of ways that we can write security codes. And a security code has got 2 letters first, and then it's got 4 digits. And no letter or digit can appear more than once. So a code is going to have the 2 letters first and then the 4 digits. So how many different codes can be formed? Well, this bit's not too bad. Let's start over here. We've got A, B, C, D, and E. And then we've got 1, 2, 3, 4, 5, 6, 7. So drawing out our little blanks, we've got 5 letters here, and the order matters. So it's 5P2 times 7P4. Right, because there are 5 ways to place the first letter, and then there are 4 letters left. And then there are 7 ways to place the first number, 6 numbers left, 5 numbers left, 4 numbers left. It's fine to do it directly like this, but you should all have a good understanding that what we're talking about is choosing 2 objects from a group of 5 and caring about the order. So remember that 5P2 can be worked out quickly as 5 factorial over 3 factorial, right? So that definition is really useful. And that gives me 16,800 ways to make those codes up. So I think that part of the question is pretty easy. For the next part, there are 2 different ways to do it. So this is the hard bit. Question C is actually fine. Find the number of different codes that include the letter A or the digit 5 or both. The easiest way to work this out is to figure out how many ways are there that have no A and no 5. So that's the cleanest way to start, right? So we're going to find the total number minus the number without A or 5. This bit here we've already got. This was 16,800. Now what about the number without A or 5? Well, we've still got the format where we've got 2 letters, right? So we've got place 1 and place 2, and then we've got to find 4 more. For the letters now, we're choosing 2 from B, C, D, or E, and for the numbers, we're choosing 4 from 1, 2, 3, 4, 6, 7. So that means that I've got 4P2 times 6 P4. And that's equal to 4 times 3 times 6 times 5 times 4 times 3. And when you times all of that together, you get 4,320. So that means that the answer to our question is going to be, sorry, the dog has just woken up, so I may have to stop this video. How many different codes that include the letter A or the digit 5 or both? It will be 16,800 minus 4,320, which gives us 12,480. And I think if you see that way to do it, that's fantastic, and that's quite a straightforward 3 marks. The other way, though, that does work, and is a good example in how to do scenarios, is to look at 3 different cases, right? So to do it directly and work out how many codes have got A but not 5, how many codes have got 5 but not A, and how many codes have got both. So I'm going to do it this way, even though it's less efficient, because this method might help you in another question. So 3 scenarios, 1, 2, and 3. No A, no 5, A but no 5, and no A but 5. Okay, scenario 1, no A and no 5. Not too bad. There are going to be, we've got B, C, D, or E here, and we've got 1, 2, 3, 4, 6, 7. So it's going to be 4 P2 times 6 P4. That's not right. Hang on. This is wrong. We don't want no A and no 5. Oh, guys, I could go back and redo this bit of the video, but I'm not going to because the dog has woken up. So we want to find the number of ways where we've got an A and we've got a 5, right? Because this is doing the direct build-up of the 3 scenarios. So forget about this. It's only one tricky thing to think about here. If we've got an A and we've got a 5, we could have the A and then something. Or we could have the something and then the A. And similarly with the second half, the 5 could be going as the first number, or as the second number, or as the third number, or as the fourth number. So that means that I've got B, C, D, and E for the second number, a second letter. And I've got 1, 2, 3, 4, 6, 7 for the other ones. So here I'm just working on this simple case of both an A and a 5. So for the letter placement, I'm going to have 4 possibilities, but I've got to times those by 2 because it could be the first or the second for the non-A letter. So 4 times 2 for that bit. And then I've got 6 numbers left, and I'm choosing 3 of them. So it's going to be 6 P3, and then I've got a times by 4 because I've got the 5 could be sitting in 4 positions, right? So that gives me 8 times 6 times 5 times 4 times 4. And when I times all that together, I get 32 times 120, which gives me 3840. Okay, so that's for case 1. So let's just put a box around that. That's the first one. Now we're going to do the same thing. We're going to do how many ways are there to get A with no 5. I can see I'm going to run out of time. So A, no 5 will be, I'm going to have A here, something else here, and no 5. So it's going to be 4 with A and no 5. 4P1, so that's 4 times 2, and then I've got 6 P4 here. So that one's a little bit easier. I don't have to think about the ordering in here. And that gives me 2,880. And then 5 and no A